Okay, part 4. Given the name, you write the formula. This one uses a little math. For this type of problem, you must show your work, either list and count or crisscross. That next line is not accurate since you'll take the test in class. So let's look at the steps. List and count method. We're going to write the symbols and charges. Then we're going to list the ions until the charges add up to 0. Then count the number of ions in each list. And finally, write the chemical formula to show the ratio, to show how many ions are in each list. You've got your periodic table with the charge pattern at the top. And that's this +1, +2, +3 share, -3, -2, -1 stable. You've got your ion chart as well. I'll go through some examples to show you the different types that you might see. So the first example here that's already done for you, calcium nitrate. You have here in calcium, you actually have what I'm calling a type 1 ion, which you just find on the periodic table. And so we're going to write calcium just like we see it on the table. We find it, it's Ca, and it's a +2. So that is why I wrote Ca +2 here. Then we look at the second word over here, highlighted in yellow, and it says nitrate. The 8 ending tells you it's a polyatomic from the negative side. Since it's a second word, remember it always goes positive, negative, and on our periodic table, positive, negative, and on our ion chart, positive, negative. So 8 means we're looking at the polyatomic ion chart, because if it was nitride, that's what it would say if it was on the periodic table. So nitrate, I see it here, NO3 -1. So that's how I knew what to write here. So now you see that's already, the second one's already there for you, but Ca +2 and NO3 -1, +2 -1 do not add up to 0. So I added another NO3 to my list, and now they do add up to 0. So that's the listing part. Now we're going to count. I see 1 calcium written here. Ca is written 1 time. So in my formula, I write Ca with no subscript. That means 1. Now I see 2 nitrates. NO3 was written twice. And so that is why I put NO3 inside the parenthesis, because that's what NO3 is, that's what nitrate is. But then outside the parenthesis, I have this 2 to tell you that there were 2 of those. So the parentheses are a little tricky, but think that through a little bit. So that one had a type 1, calcium was a type 1, and a type 2 polyatomic. Let's look at this example, lithium sulfide. So lithium is, again, from the periodic table, what I'm calling a type 1. I look for lithium, and I see it is here, and it's a +1. And that is why I wrote Li +1 over here on the list. Then the sulfide, IDE ending, usually means you're looking on the periodic table in this corner. These are the ones that all change to -ide. However, there are 2 polyatomics that have an -ide ending, so you have to watch out for those. And hydroxide, OH, is pretty common, so you will see that one a lot. But in this case, it doesn't say hydroxide, it's sulfide. So I'm going to look on the periodic table for sulfur, because that one changes to -ide when you see it in the compounds. So it's S2-. Okay, then when I add those up, +1 and -2. They do not cancel out. They don't add up to 0. So I added another Li to the list, and then they do add up to 0 now. +1 and +1 are a total of +2, and that balances against -2 to add up to 0. So now I count, and I see 2 pink LIs highlighted there, so I put a little 2 after the LI, but only one S is in the list, so I did not put any subscript after the S. Let's look at this one. We'll do 2 more. So here I have sodium is my positive one, and hydroxide is my negative one. Let's start with sodium. Since that is almost always from the periodic table, you might remember sodium, and you just can go right there and look for it, Na+1. Because remember, the only time you'll see a polyatomic coming first is if it's ammonium over here. So Na+1. For the list and count, we start by writing the symbol and the charge. Now the next word, hydroxide. You should remember that one. Try to memorize it, because that "ide" ending is going to confuse you and make you think you're looking over in this corner. But remember, that's the only polyatomic, or one of only 2 that ends in "ide." So here is hydroxide, and it's OH-1. And you see it has hydro, like hydrogen, and ox, like oxygen. So that might help you remember too. So I'm going to put OH-1. Now I ask myself, do they add up to 0? And +1 and -1, yes, they do. So that means that it is a 1-to-1 ratio, and that means I don't use any subscripts, NaOH, and I write them close together to show they're bonded. And with this polyatomic, I do not need a parenthesis, because there's only one of them. There's only one of that group. If there were 2 of them, I would have to use a parenthesis, and it would look like this, with the OH in the parenthesis and a 2 on the outside. But since there's only 1 in my list here, maybe I'll highlight it. I'll hide it with blue, since I've been using blue for the, see how that's just 1 OH? So it doesn't count as 2 just because there's 2 capitals. It's 1 group. All right, let's try one more that's got that type 3 in it, which if you're doing this before we've gotten to that, it's new, but it's not too hard. So I'm going to do this one here, iron 3 carbonate. When you see this Roman numeral, that is telling you that it's a transition metal. The transition metals are the ones that are in the middle of the periodic table, and they don't follow the pattern. So iron is this one. It doesn't really follow the +1, +2 pattern. In fact, iron, if I look on my ion chart, you see we have some of the common transition metals here, and iron can actually be stable with 2 different charges. So that Roman numeral is telling us which charge we have. If you see the little 2 lines, 2 I's, that means it's a +2. And if you see the 3, it's a +3. So I'm going to look at this again, and it says iron 3. So the ion, the positive ion here is iron with a +3. The second part of the word, then we go back to what we learned before. Sorry about that. Get that out of the way. And it's carbonate. That ATE ending tells you you're looking at the ion chart. So remember, the "ide" endings are usually on the periodic table. The ATE endings are on the ion chart. This is getting a little messy, so I will erase some things here. So I was looking for carbonate, and there it is, CO3 2-. Now my next step is to list them until they add up to 0. +3 and -2 do not add up to 0. And when you have 3 and 2, that is as hard as it gets, really. You're going to have to list a few ions on both sides to get them to be the same number but opposite charge. So I like to start on the side that kind of has too little of a charge. I see there's 2 on this side and only 3 on the other. So I'm going to put another CO3 over here. Okay, I copy it exactly the same. Now I have -4 on this side, total, and I still have a +3 on the other. So I'm going to go to this +3 side to try to balance that out. But +3 and +3 now are +6 on this side. So I need to go back to the negative side. And now they both add up to 6 in a way. So we have +6 and -6 total. And whenever you do 3 against 2, you're going to see that you have one list that's got 2 in it and one that has 3. So you'll start to see the pattern, I think, the more you do it. So now I'm going to count because they add up to 0. I'm going to count. I have 1, 2 FEs. So I'm going to write for the formula. And now I guess I'm just going to put it over here. But you guys are good at making things smaller when you have to. But FE with the little 2 after it means there's 2 of them. Notice I don't put the charges in the formulas. None of these examples do you see charges anymore because they're canceling each other out again. But there are 2 of them in the list, so that's what the subscript means. And now I'm going to do 1, 2, 3. I have 3 carbonates here, 3 groups, 3 teams. So I'm going to put in the parenthesis, I put the team just like you see it on the ion chart, CO3. I'm not changing that at all, but then I put a parenthesis to show you that team. I need 3 of them. I put another 3 on the outside. So this is the formula for iron 3 carbonate. Remember, if you have one, maybe we should do one more if you want. You can always stop watching. But here's one where we have potassium. That would be read off the periodic table. And then sulfide with that IDE ending tells you you're looking at the periodic table as well. So I'm going to look up there and find those. Take some of this away. Oops, my bad. So potassium being positive will be on the left side. Here it is. It's a +1. And sulfide being negative will be over on the -3, 2, 1 side. And it's sulfur changing to ide, so -2. So K +1, S -2. Now do that up to 0? No. I'm going to need another positive to balance that -2. Now do they add up to 0? Yes. So I'm going to count them. I have 1K, 2K. I have 2 Ks and I have 1 S. So I'm going to write K with the little 2 and then a capital S. We don't use any parentheses when it's a single atom ion like potassium, K. We don't need parentheses unless the ion is a polyatomic ion. All right, hope that helps. Thanks, bye.